Hello everybody, and welcome to your Chemistry Unit 4 review. So your Unit 4 assessment is coming up very soon before we go to spring break. So this is going to be a comprehensive review just to hit the highlights of everything that we've learned in this unit. Now, before opening this first video, you should have already read your directions for this review assignment, but if you didn't, I will just kind of explain it really quickly here before we get started. There are going to be 5 videos, so a series of review videos that go through 20 review problems. These problems are linked in a worksheet under this assignment, so you should have already taken a look at it. You can submit this assignment one of 3 ways. Number 1, if you have access to a printer, you can print the worksheet, work the problems by hand, take a picture, and upload it to Canvas. If you don't have a printer, not a problem at all. You can copy the questions as we go through them, work them by hand, and same deal. Take a picture, upload it to Canvas. Now, if you don't want to work them by hand, I'm going to give you the option to do them electronically. So you can save a copy of that worksheet, fill in your answers electronically, and then upload it to Canvas. It might be a little bit difficult to do some of these problems online, but I would rather you try to do it electronically than not do it at all. So I am going to extend that option to you. Okay? So if you guys have any questions, you can reach out to me and let me know. If you have any issues, same deal. So let's go ahead and let's get into our review for Unit 4. So this first video is going to be on Lewis dot structures and ions. So let's start with our Lewis dot structures. So remember, Lewis dots are visual representations of the valence electrons of an element. Okay, so when we do Lewis dots, we're looking at the valence electrons, which are those electrons that are in the outermost energy level. Okay, so when we do Lewis dot structures, it's similar to when we drew our Bohr models, except instead of displaying all of the electrons that are present, we're just going to be showing the valence electrons. Okay, and we should remember how to find our valence electrons, but if not, we're going to look at the group number on the periodic table. Okay, so remember your group numbers are the ones that run across the top, so they are our vertical columns. Okay, we do not do the transition metals this way. Okay, so remember your transition metals start at group 3 or 3b. So when we're looking for valence electrons, we're going to be looking for those in groups 1 and 2, and then 13 through 18. You can also see these as 1 through 8a. Okay, so that's how we find our valence electrons, and then we just fill them in. Okay, we fill in the valence electrons around the symbol, the chemical symbol of whatever element we're looking at. Well, let's do a few examples. Number 1, we're going to look at barium. So you guys should have your periodic reference tables in front of you. At this point, with everything we're doing, it's pretty much a given that you should have it on hand at all times. So let's take a look at barium. You guys should have your tables in front of you. Okay, so if we're looking for barium, barium is going to be in group 2. Okay, so group 2, right? So if barium is in group 2 of our periodic table, that means he's going to have 2 valence electrons. Okay, so when we do the Lewis dot structure of barium, you would draw your chemical symbol, right? So which is Ba. And then you're going to fill in those electrons. So there's 2 valence electrons, so we're going to start at the top here, right? And we're going to move clockwise. So here's 1 and here's 2. And there is your Lewis dot structure of barium. Let's do another one. So let's look at iodine. Again, you guys should have your tables in front of you. This is just kind of a lightning fast review. And if at any point you need to pause this video, try to work these problems on your own and then check yourself. That would probably be the best way to go about this. Okay, so iodine is in our halogen group, which is group 17 or 7a, which is going to be our indication that iodine is going to have 7 valence electrons. Okay, so we're going to draw our chemical symbol here, which is I for iodine. Okay, and we're going to start filling at the top, and then we move counterclockwise. So this is already complete, but if we were going to do this on the board or something, we would say 1, 2, 3, 4 first. Remember, you always do single electrons and then you go back in pair. So there's 4, 5, 6, and then 7. Okay, so your Lewis dot structure for iodine would look like this. Okay, let's do one more. So here we have xenon. Oops, this guy popped up a little bit sooner, but that's okay. So xenon is a noble gas, so that's in group 18 or 8A, indicating that, number one, he's a noble gas, so he's stable, and that he has 8 valence electrons in his outermost shell. So again, if we were going to fill in, even though we know he's a noble gas, we would start at the top. We would say 1, 2, 3, 4, and then we'd go back and do 5, 6, 7, 8. And again, xenon is a noble gas, so his outermost shell is full. Okay, and that is a quick rundown of your Lewis dot structures. If you need more practice or have any questions, let me know. Okay, so this first review video, we are going to move on to ions. So just a reminder, when an atom gains or loses electrons, the atom becomes charged, okay? So it can become negatively or positively charged depending on which way our electrons are moving, okay? So cations are positive, okay, indicating that our electrons are lost. Remember, electrons are negatively charged. So if you lose or you donate electrons, you're going to become more positive. So remember the way to remember this. Cats have paws, right? Cations are positive. Anions are negative. That's going to be our indication that electrons have been gained, right? Because again, electrons have a negative charge. So if an element is taking on electrons, it's going to become more negative, right? Metals on our left-hand side of the table donate and become cations. So they become positive, okay? And then our nonmetals become anions because they take on electrons. Now, why is this? Remember that the atoms want to be stable, okay? So atoms want to have a full outer shell. They want to have 8 valence electrons, or at least just a stable noble gas configuration of their valence electrons. So if they want to be stable, these atoms are going to do what's easiest. Okay, so if we're talking about the metals on the left-hand side that have, 1 or 2 valence electrons, it's easier for them to give those away to drop back down to the next energy level that's full, rather than take on a bunch to try to get to 8 in the current energy level they have. Now, on the other hand, for the nonmetals, when we think about our halogens that have 7, or our group 16 that have 6, it's a lot easier for them to take on electrons to get to an 8 outermost shell configuration. So that's why our nonmetals tend to take on electrons and our metals tend to donate them. So our metals become the positive cations and our nonmetals become the anions. So let's take a look at some examples. Here, 4 through 6 is just asking you to draw the ion for these elements. So we're going to look at sodium first. So if we look at sodium, right, again, you want to have your periodic table in front of you. Sodium is in group 1, okay? So sodium's in group 1. It's going to be a metal, all right? So it's going to become a cation. Because it's in group 1, it's got 1 valence electron, okay? So the easiest thing for him to do is donate that electron, okay? If he donates 1 electron, he's going to have a +1 charge. So you just draw the chemical symbol, which is sodium, Na, and then you're going to add a +1 charge. You don't have to put the 1 here. Just the positive symbol is indicating this charge is just +1, okay? Let's look at nitrogen now. Now, nitrogen is a nonmetal, okay? He's in group 15 or 5A. So to get to 8 electrons in his outermost shell, he's closer to 8 than he is to 0 to drop back down. So he's going to take on 3 electrons, okay? If he takes on 3 electrons, which are negatively charged, he's going to have a charge of a -3. So we're going to write this as N3-, okay? So the N for the chemical symbol for nitrogen and the 3- for the charge on the ion. Okay, let's look at one more. So 6 is oxygen. Oxygen is in group 16 or 6A, right? Meaning that there are 6 valence electrons overall for oxygen. Now, he wants to be stable, so he wants to get to 8. So 6 is pretty close to 8. So it's going to be easier for oxygen to go ahead and grab onto 2 electrons and take 2 electrons. And because, again, just like for our nitrogen, if he's taking on electrons, which are negative, he's going to have an overall charge of 2 minus. Okay? So we're going to write this with our O, our oxygen as our chemical symbol, and then the 2 minus to indicate the charge of the ion. Okay? So we've got a sodium cation, a nitrogen anion, and an oxygen anion. Okay? Again, sodium is a metal, so it's going to tend to donate and become positive. Nitrogen and oxygen are both nonmetals. They are going to take on electrons and become more negative. Okay? And again, for this whole video series, it's going to be important that you guys have your reference tables in front of you that you can refer to so you know what I'm talking about. And then the beauty of having these videos on YouTube, you can pause them as much as you want and take as much time as you need to do this review. All right, so that wraps up our Lewis dot structures and our ions. When you guys feel comfortable, you can move on to video 2.